All right, we're going to look at trigonometric substitution. So you'll notice at the top of the sheet it has a bunch of your trig identities that you may need to use in your trig substitution. So refer back to that when you need to. Let's take a look at the first integration here. So evaluate each of the following. All right, so these are definite integrals. They have indices given. And you'll notice here this one is cos cubed. So we did do some of these before, but I'm not sure how far we got. Because remember, this was in spring of 2020, so you may not have got very far. In any case, when you have cos cubed of or sine cubed, you can't use substitution right away, because remember the derivative of sine is cos, derivative of cos is negative sine. So we want to think about our power laws. So I'm going to rewrite this as cos of theta times cos squared of theta. If I can get an even exponent on cos, then hopefully I can use one of my trig identities. So if I have that, then I remember that sine squared plus cos squared equals 1. So cos squared theta equals 1 minus sine squared theta. So I'm going to substitute that in here. I'm not going to expand out because now, remembering, if I use substitution, I need to take the derivative of my expression, and the derivative of sine is cos. So I'm going to let u equal sine theta. So du would be cos theta d theta. Then I can substitute in. I'm not going to put my indices yet because I need to figure out what those are. But now you can see here cos theta d theta is there. So that's going to be replaced with du. And then I'm going to have 1 minus u squared. Okay, now to figure out what my indices are, I want to substitute in. So so my lower boundary, so that would be actually a, would be sine of pi over 3. So sine of pi over 3 is root 3 over 2. And then my upper boundary would be sine of pi, and sine of pi is 0. So you could actually, though, switch those around. In any case, we'll put those, so that's going to be root 3 over 2 to 0, and then integrate. So we can split that up. I'm going to run out of space here just a second. You're probably going to have to write pretty small. Sorry about that, but so here I'm going to have just du minus integral b squared. That's going to be u minus, and then integral of u squared is u cubed over 3. Okay. Okay, so because we found those new indices, we don't have to go back and express it in terms of theta. So it kind of saves yourself a step. So now we're going to go 0 minus root 3 over 2. Okay, then minus, and I'm going to put this in brackets, so 0 cubed over 3 minus root 3 over 2 cubed over 3. So those are obviously 0. And then that's going to be 3 root 3, so plus 3 root 3. 2 cubed is 8 times 3 is 24. And then 3's divide out. So that'll go into 8 times, so I'm going to get a denominator of 8. So that's going to be root 3 over 8. So that's going to be negative 3 root 3 over 8. Now, if we were dealing with area under the curve, then we would want to change our indices back at the top or take the absolute value. But we're trying to find the integral. So it is negative 3 root 3 over 8. Just keep the indices in that order. Okay, next one. This one has a lot of stuff. So it has cos cubed, which we did alone in the last one, and we basically split it up into cos times cos squared, replace cos squared with 1 minus sine squared. Okay, then we have sine to the fourth. So that is actually going to be the same process because we did a substitution in the last question of sine theta, and so we can do the same. So same steps here. This is going to be cos theta. I'm actually going to do all of this sort of in one here because we just did that. That's going to be 1 minus sine squared theta. And then, of course, times sine to the fourth theta d theta. Okay? And again, you can expand that out or do your substitution right away. So same substitution. I'm going to save a little space. So that's going to be, we've got our cos theta d theta, and then we're going to have 1 minus u squared times u to the fourth. It's going to be du in terms of our indices. So our lower boundary, so a will equal sine of 0. The sine of 0 is 0. B will equal sine of pi over 2, which is 1. So this is going to end up being from, oops, I guess I can put it in there, 0 to 1. Okay, and now I would just expand that out, right? So from 0 to 1, that's going to be u to the fourth du, and you can split it up or expand it and then split it up, okay? And then minus 0 to 1 of u to the sixth du, and then power law, so that's going to be u to the fifth over 5, 0 to 1, minus u to the seventh over 7, 0 to 1. So 1/5 minus 0, right? Minus 1 to the seventh over 7 minus 0. Right, so these are zeros, so we get 1/5 minus 1/7. So that's going to be 7 minus 5 over 35, which is 2 over 35. Okay. So those are ones that you probably started on last year, but it's a good review. Okay. Next one, use integrals to determine the area between those curves, so cos squared and sine squared. So we're given the actual interval. So they may not intersect. If you actually do the intersection of those two curves, they do intersect at those 2 points, but it doesn't necessarily mean that they will. If you think about, do a little sketch here. We don't do a lot with sine squared and cos squared, but you do know that for cos, the maximum is at 1 on the y-axis, so squaring that's going to be at 1. Okay, so it's, oops, just a sec. So it's going to be something like that for cos squared. And then for sine squared, it starts at 0, so when you square that, or has a y-intercept at 0, so that is going to be 0 and then go up from there. Okay, so we're finding the area between them. As I said, it does turn out that that's negative pi over 4, and that has a theta value of positive pi over 4, but even if it didn't, it's whatever is between, right? Even if it was in there. So it is helpful if you know what is the larger value in that interval, or sorry, larger function. If you didn't know, then you would get a negative value for the area, so you could take the absolute value. In this case, we know. So the area here is going to be cos squared theta minus sine squared theta. Theta. And from negative pi over 4 to positive pi over 4. Again, take a look back at your trig identities. Hopefully you remember this one. It has something to do with a double angle. It's actually equal to cos of 2 theta. Okay, and then actually, that's pretty easy. Now you could do a substitution if you want. So u equals 2 theta, so du equals 2 d theta. Okay, so half du equals d theta. So then here, integral of cos of u, du is a half du, so you can put the half out front, du. So your a value is 2 times negative pi over 4, which is negative pi over 2. B value is 2 times pi over 4, which is pi over 2. Okay, and then half. So remember, derivative of sine is cos, and derivative of cos is negative sine, so integral of cos is positive sine. Oops, don't need the integral symbol. Switched. Okay. Oh, not theta, u. Okay, so 1/2 times 1 minus 1/2 times negative 1. It's like adding a half, so that gives you 1. Okay? All right, so those are pretty standard types of trig substitution. You're just trying to get all of them into one trig ratio, sine or cos, and then just degree 1 of the other left over. Okay? Then we get into some different ones that actually don't even have trig functions in them. So take a look at this type of integral. It says functions that include factors or expressions of the form square root of x squared plus or minus a squared, or switched around, right? You could have the a squared first, can be integrated by making a substitution of x equals a times a trig ratio. Okay, in order to be able to simplify the radical to 1. Because you're hoping that you can get it into 1 minus cos squared, or cos squared minus 1. Something, well, would be negative sine squared. Can't take the root of that. But usually it's into using the Pythagorean identity, sine squared plus cos squared equals 1 is the most common. All right, so here, given what we just said, we want to make a substitution. Let's start with letting x, let's let it be sine theta. Okay, because then we would have 1 minus sine squared theta, which is cos squared theta, and then we can take the root of that. You could do cos here, and then you would end up with sine squared in there, etc. So we'll do that. And then remember dx, derivative of sine is cos. If we did the cos, then we'd have a negative. Not wrong, it's just that you have to not forget about a negative, right? So dx, that's going to be cos theta d theta. X squared, that's going to be sine squared. Square root 1 minus sine squared theta. Okay. Simplify this. It's going to be the root of cos squared theta, which is cos. So it actually, once you do a few of these, you'll kind of see that you can simplify it a little bit faster. Okay, although on a test, you should always show all your work. In the IB exam, they don't have even any multiple choice questions, so you're going to want to show all of your work. And I give you lots of space to do it. Okay, so now, what's kind of nice is those divide out. So then we get d theta over sine squared. Well, 1 over sine squared, that's cosecant squared. Oops. Okay, and if you're not sure, kind of should ring a bell that maybe there is an integral that you don't have to, you can just look on your formula sheet. If you don't have a formula sheet in front of you, then I'm going to give it to you. It's negative cotan theta. So the integral of cosecant squared theta is negative cotan theta. Sometimes on our formula sheets we just give the derivatives. So that means it would say the derivative of cotan theta is negative cosecant squared. So you can work backwards from that. This is indefinite, so we'll add our c. We're kind of done, except it's in terms of theta right now. So we have to get it back in terms of x. Now the problem is, we look at, it's back up at the top, but you can, I'll just copy it out. So this here, okay, so this was our substitution, right? So this I'm just copying down here. So we'll put a dotted line into here. So x equals sine theta. Got to get this in terms of theta, but that's cotan, right? So you want to think about, we did this back in 30-1 IB. You think about a right-angled triangle, back to your primary trig ratios. If this is theta, and we're taking sine of theta, and we know it's equal to x, so remember sine theta is opposite over hypotenuse. So we know those two sides, so then that must mean that this third side is 1 minus x squared, square rooted, okay? So now, if I am needing to take the cotan of theta, that's the same angle, cotan is adjacent over hypotenuse. So that would be the root of 1 minus x squared over x. Okay, so that final step, sometimes students forget that you need to express it back into the variable that was given. Okay. All right, let's do another one. So we've got x squared minus 25 here. All right, so this one, basically, if you have, back in the last one, it was 1 minus x squared. So it was a number squared minus the variable squared. That you sine and cos. If it's x squared minus a number squared, sine and cos isn't going to work. You're going to end up with a negative underneath there. So that's when you will want to use either cosecant or secant. In this case, I'm going to let x, still the root of 25 is 5, that's our a value, and I'm going to use secant. Okay, and basically back, if you take a look at the back page, we have 1 plus tan squared equals secant squared, so we can rearrange in there and simplify that radical. All right, derivative of x is dx, derivative of 5 secant theta is 5 secant theta tan theta d theta. Again, use a formula sheet. You don't have to have those memorized. All right, so here we're going to do our substitution. So it's going to be square root. So that's going to be actually 20, well, maybe I should put it in there. 5 secant theta squared minus 25. X is 5 secant theta. And dx is 5 secant theta tan theta d theta. Okay. All right, so that's going to be 25 secant squared minus 25. So you can actually show that factored. And this divides out, the 5 divides out, so we're left with tan theta d theta. Square root of 25 is 5. I'm going to put that out front. And then secant squared theta minus 1, as I said, look on the front page of the notes. Secant squared theta minus 1 is tan squared theta. That's going to be tan theta times tan theta, which is tan squared theta. Okay. And then now, this we don't know how to take the derivative, the integral of tan squared. But remember, we've done ones like this before. Get it down into your primary trig function. So that would be integral of sine squared theta over cos squared theta. I should check the IB booklet if they might give that to you. I don't know. Anyway, you can always figure it out on your own. Okay, so then I'm going to use my identities. Okay, so that's going to be 5. I'm going to split this up now into 1 over cos squared theta, which is actually secant squared, and then minus 5. Cos squared over cos squared is 1, right? Times 5 is 5, so you can leave that out front. 5 integral of secant squared. Now you can figure this out. That would be 5 theta. Put the c in. Then the integral of secant squared is tan theta. So this will be 5 tan theta minus 5 theta plus c. Again, problem is in terms of theta, not in terms of x. So remember, we let x equal 5 secant theta. So that means x over 5 equals secant theta. Do our triangle. If this is theta and secant is x over 5, that means cos theta is 5 over x. So 5x, and this would be x squared minus 25. All right, so then this is going to be equal to 5. Tan of theta is root of x squared minus 25 over 5 minus 5. Now theta, notice how it's theta by itself. So I'm just going to go back to this, go back to primary trig ratios, obviously inverse here. So theta is going to be cos inverse of 5 over x, and then plus c. So I can simplify the 5s a little bit here. So this is going to be root of x squared minus 25 minus 5 cos inverse of 5 over x plus c. Okay. Remember, pause the video anytime you need to. All right. Last one. This is a little bit different, right? Functions that are quadratic, that cannot be factored, but that can be expressed in the completed square form, basically, can be integrated by making a substitution of x minus h equals a tan theta in order to simplify. So this one here, basically you're going to complete the square on this. We're back to math 20. That was a while ago. So that's going to be x squared minus 4x. Half of negative 4 squared is negative 2 squared is 4. And then minus 4, and then plus 8. Right? Negative 4 is not going to change, so that's going to be x squared minus 4x plus 4, which factors to x minus 2 squared. Negative 4 plus 8 is plus 4. So we can show this as x minus 2 squared plus 4 dx. We haven't made any substitutions. We've just shown it in a different way. Now it says to make a substitution. So it says x minus h. So that's going to be whatever's in here. So x minus 2 equals the root of 4, which is 2 in this case. Happens to both be 2's, but that's just by chance. Tan theta. Okay, so then really x equals 2 tan theta plus 2. If we take the derivative, remember derivative of tan is secant squared. So 2 secant squared theta d theta. Derivative of 2 is 0, right? So now we can replace our x with 2 tan theta plus 2. X minus 2 is replaced with 2 tan theta, and then we have to square it, plus 4. And dx is replaced with 2 secant squared theta, d theta. Okay, so then we can do some factoring here. So I'm going to factor out a 2. 2 tan theta plus 1. Here, that's going to be 4 tan squared theta plus 4. So I'm going to factor out a 4. Okay. And then multiply by 2 secant squared theta d theta. Obviously that goes in, twice. And then take a look, formula sheet. 1 plus tan squared is secant squared. So this denominator becomes secant squared. And I'll bring the half out. Oh, but there's a 2. Right, so this is 2, so these all divide out. So we don't even need the half there. Those divide out. So then we get integral of tan theta d theta is the integral of d theta. Okay, and then same deal. We'll show this as sine over cos. That's going to be theta c. I'll just put the c there. You can wait till after you've done this integral. U equals cos theta, so du equals negative sine theta. So that's going to end up being here negative d theta, negative 1 over u du, which is negative ln of u. Now you need to have the c in there. Okay, so now let's go back. We have to keep it within x, so we need to put the thetas back in. So u is cos theta. Then we look at our original substitution, right? So we had x minus 2 equals 2 tan theta. I want to solve for the trig ratio, right? So that means tan theta is x minus 2 over 2. So tan is opposite over adjacent. So then this would be here, x minus 2 squared plus 4. Okay. Notice where that comes from. All right, so now negative ln. So cos is adjacent, so that's going to be here 2 over root of x minus 2 squared plus 4. Now, do you need the absolute values? Actually, not really, because that's always going to be positive. And then with theta, So we have this here with theta. So if we want to solve for theta here, that would be tan inverse of x minus 2 over 2. All right. So that was a toughie, but try it again, do something similar. There'll probably be some practice to work on. So that's done.